Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So today's problem of the day is move zeros. As you can see here, the problem statement says कि given an array of integers and your task is to move all zeros to the end of the array while maintaining the relative order of the non-zero elements. Means you have to shift all non-zero elements towards the left side, but its order should be same. Means you cannot sort it here. Okay. The constraint says 10 power 4. Okay, so the num's length can go from 1 to 10 power 4. Means the brute force approach with O of n square time complexity can work here. But still it says कि could you minimize the total number of operations done? Means it has been asked to optimize your code here. So let's come on to the screen. The problem says कि you have been given an array and here you will get non-zeros and zeros elements, and your task is to shift all the zeros towards the right side. Means the output will look like 1, 3, 12, 0 and 0, and it says that the order for non-zero should be maintained. Means it cannot be 12, 3, 1 and then 2 zeros. No, it cannot be. Why? Because the order will be hampered. Means here if you are thinking to sort it, that will fail, because if you will sort the elements here, then order might get hampered. So in this case also you can see that you have to put all the zeros towards the right side. So you would like to go with the descending order sorting, correct? So if you will sort accordingly, you will get 12, 3, 1 and then 2 zeros, and hence 12, 3, 1, the order has been hampered and hence you are not allowed to sort. So you have to go and pick up the elements and then put it accordingly. So let's see the brute force approach. What can we do here? So here we want all the non-zero elements in the same order. So for this we can simply run a for loop and get all the non-zeros in the same order 1, 3, 12. How? We can run a for loop with I pointer and we'll say, hey, are you non-zero? No, you are not. Hey, are you non-zero? Yes, you are. So go in the array 1. Now it will ask, hey, are you non-zero? No. Hey, are you non-zero? Yes. So after 1, 3 will be inserted. So if you will run a simple for loop now to check whether it is not equal to 0, and then you will simply put in the outer array, you can get all the non-zeros in a relative order. And similarly, you can make another array to put all the zeros here. Or even if you don't want to make all the zeros, simply what you can do, you have inserted all the non-zeros, correct? So total length minus this length will be nothing but number of zeros. Yes. How? I said total length. So what is the length of this? Total 5, correct? And what is the length of non-zero elements which you have inserted in the resultant array? 3. So non-zero and total length, if you will subtract this, 5 minus 3 is equal to 2, and 2 is nothing but the number of zeros here, correct? So those number of zeros you can simply insert in the same resultant array and you can return it, correct? But in this case you have to make another array for this, and the time complexity will be O of n, but space complexity will also be O of n, because you have created an extra array here. But what if the question says you have to optimize your space as well? How would you like to solve this question there? Let's see. I hope for this brute force approach where we are creating the new array, you can solve it. Now let's see the optimized code here. So for all the optimized approach, we know there are 4 patterns in array. 4 patterns where first were 2-pointer approach, second was sliding window, third was prefix sum, and fourth was cadence. And you know that we have already discussed in the very first lecture of the video that sliding window, prefix sum and cadence we will be using when we want continuous subarray or continuous subarray summation, length, etc. But whenever we want to play with a particular elements, 2-3 different elements, then there we go with 2-pointer approach. And here also we want 0 element and we want non-zero element so that we can swap it, correct? So basically we want 2 pointers at different locations. So that will be solved using 2-pointer. And if you still have any doubt, you can surely check out our very first lecture where we have discussed all the patterns of arrays in detail. And that is the reason why we are going to apply 2-pointer and not sliding window, prefix sum and cadence here. So if you know all these 4 patterns of arrays, then you surely know how to optimize the brute force code in array. So without any further delay, let's get started with the optimized code. So the optimized approach is very simple. We will use 2-pointer. Suppose the very first will be left and this will be right. Okay, so left will take care of all the non-zero values towards itself, and right pointer will be just moving forward and checking, hey, are you 0 or are you non-zero? Simple, correct? So at the very first, right will ask ki, hey, are you 0 or non-zero? It will say, hey, I am 0. If it is 0, no need to swap. Okay. Now after that, right pointer will move to first index and it will say, hey, are you 0 or are you non-zero? It will say, hey, I am 0. And if you are 0, do one thing, swap yourself with the number pointing by left pointer. Okay, swap yourself. So it will swap, it will become 0 and it will become, and this will become 1. Okay, this has been swapped. And if this has been swapped, along with your right pointer, your left pointer will also move. Why? Because left pointer is nothing but the location where the upcoming non-zero should be placed. Again repeating, left pointer is the place where the upcoming non-zero elements needs to be placed. So that is why when you have swapped it, means you have actually inserted the non-zero element. So you need a new place for the another non-zero element. That is why left pointer needs to be moved ahead. I hope this point is clear. Now after this, again right will ask, hey, are you non-zero? It will say, no, I am 0. Okay, so again if this is 0, right pointer will simply move forward without even swapping. So what we are doing, we can write this simple point in the code, correct? What? If nums of right is not is equal to 0, correct? Then only swapping needed, correct? Okay, okay. And if not, then swapping is not needed. We will simply do right plus plus. Or else we can write this in a simple for loop also. Int right is equal to 0, right less than nums of length and right plus plus. Okay. So this for loop will take care of incrementing the right pointer automatically. Okay. Now the thing is, if this is non-zero, then we have to write the swap logic, correct? We have to write the swap logic. So what is a swap logic? So we will store in the temp variable, what we will store? We will store whatever is there at right index. Okay, because this is non-zero, but we don't know what is the exact value there. Okay, and at nums of right, we would like to keep the number which is there at nums of left, which is nothing but 0 mostly, except the base case where left and right pointer pointing to the same element, means length is 1. We'll see that. So that is why we are not directly writing 0 here. Then after this, our task is to put at nums of left pointer, we have to put whatever were there at nums of right, which we have stored in the temp variable. Okay. After this, what is our task? We have to do left plus plus manually, because right plus plus has been taken care in the for loop, and because we need this extra pointer left, so we have to initialize this outside int left is equal to 0. So this is our very simple code for this. So let's dry run this. So where were we? Ki this right pointer is pointing to non-zero. Okay, if this is pointing to non-zero, what is our task? Our task is to swap it with left. So now again this 0 will come here and this 3 will go there, correct? So can we directly swap? Yes. Yes, we'll write 3 here and 0 here. Done. So what we say, if swapping is done, then right pointer to for sure will move even if it is 0 or non-zero, but left will move if right was non-zero. So now left say ki, hey, earlier I had a place where non-zero needs to be placed, and since you placed it, so move me to a new index so that another non-zero can come here and place itself. Okay, now again this right pointer will say, hey, am I non-zero? Yes, I am. So what is the new location where I am pointing to, or I should be placed? So left simply says, come here, I have a place for you. So now it will again swap itself. So 12 will come here and 0 will go there. So 12 will come here and 0 will go here, correct? Again left pointer will move itself and right pointer will move itself, and as right pointer is out of index, means this for loop will break, and once the for loop breaks, after this we know ki all the nums array has been swapped, and if it is swapped, we can simply return our answer if the question asks, or else if the question asks only to manipulate, not to return, we can simply stop our code here only. So let's see what is the time complexity in this case. What was the time complexity? Our right pointer started from 0 index to n minus 1. Apart from this, even if we are using the left pointer, but left pointer we are only using to swap, that only takes O of 1 time complexity. And even if we are doing left plus plus, but at the same time our right is also moving forward. You remember there were two cases. When our right was pointing to 0, left was not moving, and when our right was pointing to non-zero, although left was moving, but right was also moving at the same time. So that is why the total time complexity is nothing but the number of times right moved, and right moved from 0 to n minus 1. That is nothing but the total time complexity is O of n in this. So this is the code in a single pass where we have not used any extra space complexity. We just use the variable that is constant space. So let's move on to the code. We will simply calculate the length, nums dot length. After this we want a left pointer, correct? So int left pointer is equal to 0, and we want to run a for loop for the right pointer. So int right, start from 0, right less than n, right plus plus. And after this our task was to check if nums of right is pointing to 0 or not. So if nums of right is not is equal to 0, means it is non-zero, and if it is non-zero we need to swap. So for swap we first store the value of nums of right in the temp variable. We would like to swap with nums of left, and we have to put at left also. So that is nothing but temp, because whatever was there at nums of right we have to put at nums of left, and at nums of right whatever were there we have stored in our temp variable. After this we have to do left to plus plus. Right plus plus we won't do because that will be taken care by the for loop itself. Do the question ask to return anything? No, it does not. So let's run this. So now let's submit this. See, our code has been passed. So this was the Java code we all know, and here is the Python code with the same logic, and here is the C++ code with the same logic. I hope this question was clear because this was very easy also. And if you have any doubt, do let me know in the comment section. And with this, we are done with the fourth question also, which is move zeros. And what we are doing, we are actually following our Rising Brain pattern-wise DSA sheet. And with the very first pattern 2 pointer, we are done with the fourth question as well. If you are new to this channel and if you really like the way of teaching and the idea of solving all the questions pattern wise, then do hit the subscribe button, like button, and share also with your friends. And if you want this free DSS sheet link, you can get that from the description below. And if you want to connect with me on LinkedIn or Instagram, all the channel links are there in the description below. And that's it for the video. Let's meet in another video with some more interesting topic and questions. Till then, keep learning, take care of yourself and your family too.